I'm going to make example 3, example 4. Okay, so I'm just going to go ahead and run example 4 just as a sanity check, right? Make sure it all works. So I'm still working on my modified NIST data set. So that's all good. I'm still extracting out my data. I'm still doing a 5 tester a 5 detector. So that's good. I'm still going to be training a stochastic gradient descent classifier. So that's good. Still going to be doing my same training on my X train and my Y train _5. So that's also fine. And still going to be building my confusion matrix, right? I like the confusion matrix. We can even leave these plots here if you want. So what I'm going to come down here is I'm going to create a new section at the end of a somewhat long code, but that's okay, called precision and recall. And so calculate the precision and recall values. Well, before we calculate precision and recall, we need to get our true positive and our true negative, right? So we printed the confusion matrix, which is fine. So I'm going to come up here and call it confusion matrix is equal to what we had. And then I'm just going to go ahead and print my confusion matrix. Hit F9. Okay, now I've saved my confusion matrix. Okay, so get my error types. And that is going to be true negative is equal to confusion underscore matrix 0, 0. False positive is equal to confusion matrix 0, 1. False negative is equal to confusion matrix 1, 0. And true positive is equal to confusion matrix 1, 1.
Can you show the code you did to save the confusion matrix?
Sure, absolutely. How about I move it down here? Maybe that would just be, oh wait. So, yeah, did that work? So confusion matrix sk metrics dot confusion underscore matrix.
Okay, so that was just some. Okay,
yeah, so it's exactly what we had before, but I added confusion matrix equals, and before I was just printing it. I hadn't saved it to a variable before, right? I was being lazy because that's who I am. That is not a true statement. I wish it was. I wish I. No, I like eating. Okay. So calculate precision and recall. Okay, so calculate the precision and recall. So for that, we need, oh wait, I don't know why I created a whole section for that. That's not smart. Let's just go accuracy underscore SK is equal to SK dot metrics dot accuracy underscore score. And for that, oh wait, I'm sorry. I'm going to take that entire thing back. Accuracy is equal to TP plus TN divided by TP plus TN plus FP plus FN. And now confusion matrix is not defined. Did I spell it wrong?
You spelled it wrong up at the top.
MATRIX. I thought so. Thank you. Okay, so accuracy is 97% on that model. That's pretty good, actually. That is very good. So let's take a look at our precision. So precision is equal to TP divided by TP plus FP. And recall is equal to TP divided by TP plus FN. So let's see what my precision is. 86%. So if I just report my accuracy at 97%, I'm doing awesome. When I tell you I have an 86% precision, that is a very different number. Does that make sense? And then let's take a look at my recall. 83%. Accuracy is really not a good metric for really it's not a good metric. Unless I calculated my metric wrong. TP, TN, FP, FN, that looks right. Sometimes you got to check. Okay, so does that help understand the importance of accuracy, precision, and recall? Right? So, of course, we can do this like this every time, but let's be honest, like sklearn has this built in. So why don't we just use the sklearn parameters and see if we get the same numbers? Accuracy under sk is equal to sk.metrics.accuracy underscore score y underscore train underscore 5 comma x underscore train underscore predict. Precision. So let's just ACC URACY. All right, so let's see what that gives us. 97% accuracy. That's what we had before, right? 97,395. Perfect. So our accuracy number was right. We can type this all out each time, but that's kind of lazy. So, I mean, kind of boring. So I'm just going to copy it 3 times. And I call it precision underscore SK. And that's precision. And then recall underscore SK. Recall. And I get 86% on my precision and 83% on my recall. So it's good to know that it calculates it the same way and we get the same values. All right, so let's do an F1 score. You could calculate an F1 score by hand also, but let's just go F1 is equal to sk dot metrics, same thing, right? But it's instead of recall score, it is F1 score. And F1 is equal to 85%. So if I just report my accuracy, I actually get a very good number because the majority of mine are calculated right. But if you actually care about how many there are versus how many are calculated, like with precision and recall, it gets much worse. And my F1 score only reports 85%. Who would buy a product that reports a 97% accuracy, right? Who would sit on a jury, right, and be told by an expert they have 97% accuracy and feel pretty confident about your decision, right? If I say that same number with an F1 score of 85%, how confident are you? Right? Who would buy a product that has an 85% F1 score? Depends on the product and what you're doing, right? So these are very important questions to ask. Accuracy can just be, there's a lot of numbers and most of them are good, right? But if you had an accuracy of 97%, right, and you were trying to send things through the US mail system using this system, mail would never get anywhere, right? Because 1 out of 10, right, almost 2 out of 20 would not make it to where you want it to go. Okay, so that's our F1 score. So let's adjust the threshold and see what we get. So let's plot the precision and recall over the threshold domain. So first, compute the scores for the prediction. So y underscore scores is equal to sk.model underscore selection dot cross val predict. Stochastic gradient descent underscore CLF classifier x underscore train y underscore train underscore 5 cross CV cross validation is equal to 3. I understand a lot of this we haven't talked about, but that's okay. We'll get to it. And then method is equal to decision underscore function. All right, so let's see if that brings me out some scores. And while it does, I'm going to break it into 2 lines. So this is getting a score. So we've trained a classifier. Now I'm going to get a score for each one of these values, right? For between what I trained on and what my 5s are, using a cross validation of 3. That's just going to move data around a bit. We'll talk about that later. So now I've got Y scores. And these are my scores of whether or not this is a 5. Right? So this is really what I'm getting. Everything negative is not a 5, but 978, right? It's not just telling you if it's a 5. It's telling you I'm going to give you a negative 15,974 value score that it is a 5, which means it's probably not a 5. 978 could be a 5. It's more 5-ish than this one. 3,681 could be a 5. Let's see if we can find some red ones. Or some really blue ones, I guess. Kind of hard. There's a really red one. Negative 95,000, not a 5. Whatever that is, it has very few pixels that are light where a 5 is supposed to be light, and very few pixels that are dark where a 5 is supposed to be dark. Maybe it's the inverse of a 5. I'm just colored in around the outside, right? Okay, so that's what the score is giving us. For the scores and target training set, calculate the precision and recall and threshold values. So we're going to go precision, PRECISIONS, precisions, recalls, thresholds is equal to sk.metrics.prediction underscore recall underscore curve y underscore train underscore 5 comma y underscore scores and that should give me my precision recall prediction precision PRECISION. That should give me my precision recall curve data. But it doesn't give me my recall, my F1 score. So now I want to find my F1 score. And so that's pretty easy to get. F1 is equal to 2 divided by 1 divided by precision CISION precisions plus 1 divided by recall. Two L's. I need an extra L up here would be correct. All right, now I have my F1 scores. I'm going to assume that they work, so I'm just going to go straight to the plotting, right? So plt.figure, plt.plot, thresholds, comma precisions. So if I look at my thresholds, I have a, you could just do it too and figure it out. 780.
Professor, line 148, I think you're missing an L in thresholds.
There you go. Come on. Well, anyways, let's just go ahead and try this. And what we'll see, we don't need to look, is that we have two different shapes, 59980 and 59981. But the threshold sits between two data points, right? So it's going to have one less point that it can be. So we just have to cut one. So we're just going to cut one from precisions. When you have that many data points, it's really not not a big deal. And now we have plot, and that is what my precision looks like. So my precision starts very low and goes up, and kind of has a weird little jump here, which is interesting. And then kind of a collection of threes up there that are maybe messing it up. plt.plot thresholds, comma, recalls, same issue, up to, from everything up to -1. I'm going to give it a label. Recall. Give this one a label too. Precision. plt.legend. And now if I go ahead and hit F9, I should get my recall and my precision, which I get. Precision and recall. So that looks pretty good. So far, so good. Kind of what I would expect. And now let's go ahead and plot my F1 score. I'm just going to copy this. F1's F1 and there's my F1 score, right? Kind of a little bit at 80%, just a bit below. Looks pretty good. Pretty good. Depends on where you kind of put your put your threshold. So if I zoom in on this, what does this actually look like? So if I recall, my F1 score was 85%. But that has a different precision value. So we'll have to look at that a bit. Well, we can play around with that data a bit more. But for this current threshold, I peak. If I move my threshold a little bit to the left, I can get 77% on an F1 score across the whole data set. So let's suppose you want to aim for 90% precision, and you look at the first plot, and you find that you need a threshold. So if I want 90% precision, I need a threshold. Oh, with the current model of about 2,000, 25. Let's just go 3,000, right? So how do we set that? So to make a prediction on the training set for now. So to make a prediction, instead of calling the classifier's predict method, you can run something that looks like this. To make a prediction, you can run this code. Go x_train _predict _90, because that's kind of what we're looking for, is equal to y of, sorry, that's not what I want. I want a tuple of y_scores is greater than, what do we say, 3,000? How about that? And now I can recalculate my accuracy. I'm just going to go up here and copy my accuracy, precision, and recall. But I'm only going to take my X-train prediction for the 90. And then I can go ahead and put a 90 here if I wanted to separate them. And now I should be able to hit F9. That should all run. And by just extracting out some of my subset, I can get a precision of 92%, right? By only training, by only taking my data that has an X score of greater than 3,000. So if I'm only considering subsets of data, then there are easier ways, or there are ways to get up to a 90% precision.
So if I'm getting a different precision, does that mean I'm doing something wrong, or is that because we don't have the same random seed?
We don't have the same random seed. I am astonished how well this is predicting. Is yours predicting this well?
No, it's at 69.
That makes more sense. I think I just got super lucky and I was rolling with it. Right? Life doesn't throw you a lot of freebies, but yeah, I mean,